Hey guys, in this video, we are going to learn about composite functions and how you use composite functions to tell if the two functions that you've been given are inverse functions, okay? So the first thing I'm going to do is give you a definition here, and that is for a composite function. So a composite function is basically a function that is written inside of another function. Most often you'll see it written like this, f of g of x, or you'll see it written like this, g of f of x. So it's like you're writing one function inside of another one. And that'll make more sense once we look at a problem down here, okay? So composition of a function is done by substituting one function into another function. Okay, so you're going to be substituting one function into another function. Now, as we get down here, I'm going to give you some examples to show you how that's going to work. But I want to give you one other definition. Two functions, f of x and g of x, are inverse functions. Here's that word again, if and only if. That means you have to meet both sides of this. If and only if f of g of x, that's that composite function, equals x, and g of f of x also equals x. They both have to do it. So notice we flipped the order that we did it in, okay? Now, what I'm going to tell you is that basically what f of g of x means is that you're taking f of g of x. And what g of f of x means is that you're taking g of f of x, okay? Now, these two things right here, I think will help you more than anything when you first start doing this, okay? So let me go down here and show you what I'm talking about and how we're going to use this information. So determine whether f of x equals 4x plus 1/3 and g of x equals 1/4 x minus 3 are inverse functions. We want to know if they're inverse functions. Now, according to this definition up here, if they are inverse functions, when I find this composite function, it's going to equal x. And when I can find this composite function, it's also going to equal x. So if both of these equal x, then these two functions are inverses of each other. So let's first check to see, does f of g of x equal x? Does it? So remember, f of g of x equals f of g of x. So what I'm going to do is I'm going to look up here and I'm going to see what g of x is equal to. Well, g of x is equal to this right here. It's 1/4 x minus 3. So I'm going to put in the place of that g of x, I'm going to keep that f, but in the place of g of x, I'm going to put what g of x is equal to. It's equal to 1/4 x minus 3. Okay, I'm going to write that in there. Now, you know that when you have f of a number, like f of 2, then that means you take that 2 and you replace it in for x. We're going to do the same thing, but we're just replacing it with something bigger. So notice this time, I'm replacing it with this, the 4x plus 1/3. So this time I'm saying, okay, that means I put the 4, and then in the place of x, I'm going to put this right here. 1/4 x minus 3. And then I still have this plus 1/3 out on the end. Okay, now it becomes algebra. So I'm going to distribute that 4. 4 times a fourth is just 1, so that's going to be 1x. And then 4 times negative 3 is negative 12. Plus 1/3. Okay, then this x I can't put with anything, but negative 12 plus 1/3, that's negative 11 and 2/3. Now, this over here already does not equal x, right? This does not equal x. So if f of g of x does not equal x, then I don't even have to consider doing the g of f of x to see if it equals x. Because remember, I have to meet both of these stipulations for them to be inverses. So I would say no, since f of g of x does not equal x, these two functions are not inverse functions. Okay, let me do another example for you. Determine whether f of x equals 2x minus 7 and g of x equals 1/2 times x plus 7 are inverse functions. So remember, if they are, f of g of x has to equal x and g of f of x has to equal x. So let's first check f of g of x. Remember, that means f of g of x. So we're going to put g of x right in here. Okay, whatever g of x is, we're going to put it right here. Now I'm going to circle again this g of x over here. So that means I'm putting in the f, and then in the place of g of x, I'm going to write 1/2 x plus 7. Now I'm going to take this and go to the f of x equation, and I'm going to put this whole thing in for that x right there. Okay, so now I've got 2, and then I'm going to have to put it in brackets since there's a parentheses there. 1/2 of x plus 7, I replace the x with that, minus 7. Now this is all multiplication here. 2 times 1/2 times x plus 7. So 2 times 1/2, half of 2 is 1. So that means I'm just left with x plus 7 in there. Okay, because 2 times 1/2 equals 1. Then I've still got a minus 7. Okay, now that leaves me with x because 7 minus 7 is 0. Okay, this one is looking good because I ended up getting the f of g of x equals x. And remember up here from this property, I have to get f of g of x equal to x, but I also have to get g of f of x equal to x. So I've got one of them. Now let's check the other one. Okay, now I want to see if g of f of x, does that equal x? So remember, that means g of f of x. Okay, so this time I'm replacing this f of x here with this 2x minus 7. Okay, so that means g of 2x minus 7. Okay, now I'm going to take that 2x minus 7 and I'm going to go to the g function. So here's my g function. And in the place of this x right here, I'm going to put 2x minus 7. So now I've got 1/2 times 2x minus 7 plus 7. Okay? Now, minus 7 plus 7, both of those are in here. So minus 7 plus 7, those are going to go away, and that's going to be 0. Then that leaves me with 1/2 of 2x. Well, half of 2 is 1, so that'd be 1x. So I did get x. So since I got x here, and I got x here, then yes, these are inverse functions. Yes, they are inverse functions. Okay, I would like for you to pause the video and try to do this try problem. Determine whether f of x equals 3x minus 1 and g of x equals 1/3 x plus 1/3. You try that one, pause the video, and then I'll come back and work it. Okay, hopefully you've worked this problem. And remember, you're wanting to check to see if f of g of x equals x and if g of f of x also equals x. That's what we need to happen if they're going to be inverses, okay? So let's first check f of g of x. That means f of g of x So I'm going to replace g of x with this over here. So that's f of 1/3 x plus 1/3. Then I'm going to go to f and put this in the place of x. So now 3 times 1/3 x plus 1/3 minus 1. Okay, I've got to distribute here. 3 times 1/3 is x. And then again, 3 times 1/3, it would be 1. Okay, 3 times 1/3 is 1x, and then 3 times 1/3 would be plus 1. And then you've still got your minus 1 out there. Okay, so now plus 1 minus 1, that's 0. So you're left with x. Okay, this one's looking good. I ended up with x. Remember up here, that's what we wanted. Okay, now let's see if the other one works out that way. Does g of f of x also equal x? So that means we're looking for g of f of x. We're going to replace this f of x with this over here. So g of 3x minus 1. Now we're going to replace this 3x minus 1 in for this x in g. So we've got, sorry, I shouldn't put the g there. So now we're going to put 1/3 times 3x minus 1 plus 1/3. Okay, we got to distribute here. 1/3 times 3, that's 1x. 1/3 times -1 would be a -1/3. And then we have plus 1/3. Okay, minus 1/3 plus 1/3, that's 0. So those go away, and we're left with x. So both of these ended up being x. If they are both x, then yes, f of x and g of x are inverse functions. Okay, as always, if you have any trouble, let me know.